In this exercise, we are to express the sum given in a traditional way using sigma notation. Since sigma refers to addition, we'll first rewrite the sum in such a way that we have only plus sign between the terms. So we'll have 3/4, and instead of minus 4/5, we'll write plus and negative 4/5. And to continue with the rest of the sum, we'll have 5/6 plus negative 6/7 plus 7/8 plus negative 8/9 plus 9/10 plus minus 10/11 plus 11/12 and finally plus negative 12/13. We have addition, and now we want to write this sum using sigma notation. Before we'll do that, we'll have to figure out what sequence we are dealing with and what are the terms of the sequence. So let's look at the sequence. The first term we are adding is 3/4. The second term is negative 4/5. Then we'll have 5/6. And then we'll have negative 6/7. And then positive 7/8, and so on. So we need to find the general term of that sequence, a sub k. The first thing that we can notice is that we have alternating sign. First term is positive, then we have negative term, positive and negative, and therefore we'll have negative 1 to the power k plus 1 because we are starting with the positive value as the first term. So now we'll build the formula. We'll look for relation between the terms of that sequence and the values of k. We can easily notice that the numerators are always 2 more than the value of k. So numerator should be k plus 2. And the denominator is always 3 more than the value of k. So this is going to be k plus 3. And we are starting with k equal 1, and we'll continue. The last term is in our sequence is negative 12/13. So to get negative 12/13, we'll have to go with k equals 10. And therefore, at this point, we are ready to write our sum in sigma notation. That's going to be sum from k equal 1, because that was our choice, to 10. And here we'll write the general term of that sequence, negative 1 to the power k plus 1, and then k plus 2 over k plus 3. Notice that that sum could be rewritten differently if we look at the sequence not starting with k equal 1 but with k equal 3. If we start with k equal 3 and the term is 3/4, then the next term will be negative 4/5 for k equals 4, and will end with negative 12 for 13. You can see the relation between the terms of that sequence with k starting with 3. The ak here would be negative 1 to the power k plus 1. This will not change, but the numerator now is going to be k, and the denominator is going to be k plus 1. And we'll start that sequence at k equal 3, and this one will end when k is equal 12. And therefore our sigma form can be written as the sum, also in different form, from k equal 3 to 12, and the term of the sequence is the same. We are just changing it the way we count that values of k. It's going to be k over k plus 1.